Welcome back. Now we're showing hit numbers whenever we shoot the enemy, and we're also storing those hit numbers in our hit numbers map and deleting them after 1.5 seconds. But during those 1.5 seconds, that hit number will still follow the screen space location of the center of the screen, and we want that hit number to be updated according to the hit location of the bullet. So let's take care of that in this video. Now I'm here in enemy.h, and I'd like to create a function to update those hit numbers. So I'll create a void function here, and this function will be called update hit numbers. And we can use this function to update the screen space location of each hit number every frame. Let's create a function definition for this. Now each frame, we need to update the location of every hit number in our hit numbers map. So I'm going to use a range-based for loop. Here's how it looks. I'm going to use an auto reference called hit pair and loop through hit numbers. Now, if you haven't used range-based for loops much, all this does is loops through the hit numbers map. So we have access to each hit pair and hit numbers. Now, hit pair is of type T-pair. That's the type that a T-map holds. A T-pair contains a key and a value. So we're looping through each pair and hit numbers, and we can access the key and value from each T-pair. For example, if we want the key, which is of type UUserWidget, we can create a local UUserWidget pointer called hit number, and we can initialize it with the value of hitPair.key, since the T-pair type has a member variable called key. We can also access the value, which is of type fVector. So if we create a local fVector called location, we can initialize it with hitPair.value, since T-pair has a member variable called value, which stores the value of the pair. Now we don't plan on changing the hit location, so we can make this local variable const. Now we need to take our hit number and update its screen space location, and uGameplayStatics has a function just for that. So let's use uGameplayStatics, and the function we want is called projectWorldToScreen. Now projectWorldToScreen takes a player controller as its first argument, and we can get a player controller using getWorld getFirstPlayerController. So that passes in a player controller satisfying the first argument. Now the second argument is an fVector, which is the world position that we want to project to the screen. We're going to use the location, which is the hit location for this particular hit number. So pass in location. Next parameter is an fVector2D called screen position. Now this is passed in as a non-const reference, which means we're passing in an fVector2D, and projectWorldToScreen is going to fill that vector in with the screen position that corresponds to our world location. So we need to create a local variable of type fVector2D. So we can call this screen position, and we're going to pass that into projectWorldToScreen. So screen position gets passed in, and after we call this function, screen position will now have the position on the screen corresponding to our hit location. I'll go ahead and put each argument on its own line for readability. So now we have the screen position corresponding to the hit location for this hit number. Now all that's left is to set that hit number's position. So we can take our hit number and call the function setPositionInViewport. And setPositionInViewport takes an fVector2D for the screen position. So we're going to use screen position for this. So now update hit numbers is looping through each hit pair in our hit numbers map and accessing the hit pair's key, which is a UUserWidget pointer, and the hit pair's value, which is an fVector. We're then projecting that hit location onto the screen, so after we call projectWorldToScreen, our local screen position variable has that screen location, and we're using that to update the hit number's position in the viewport. So we need to call update hit numbers each frame, so we're going to call this here in tick. Let's go ahead and compile this and test it out. Alright, so we're going to go ahead and shoot at the enemy and see how these numbers behave. So now we're moving the camera and those numbers are staying at their hit locations, which is exactly what we wanted. Okay, that's going to conclude this video. In the next video, we're going to work on binding the text for the hit numbers so they actually display how much damage we're doing rather than this default value of 3. I'll see you in the next video.